Hi, my name is Tyler Sisley. I'm a biochemistry major of the class of 2018, and today I'm going to be showing you some techniques for calorimetry. The basic parts of a calorimeter are the insulator, the lid, the thermometer, and the stir bar. Our temperature probe will serve as both the stir bar and thermometer today. Our reaction mixture is water with a known specific heat capacity. We will measure its temperature change when it absorbs heat from the metal, and we can extrapolate the specific heat of the metal using its data. The materials we will need today are a USB adapter, a temperature probe, a lid, 2 styrofoam cups that will stack on top of one another to make our calorimeter, a beaker of cold water, a beaker of hot water, an alcohol thermometer that we'll use to measure the temperature of the hot water, some hot pads to hold the hot water beaker, forceps, and an unknown metal. The first thing you will want to do is put one of your beakers with water on the hot plate and put the heat on high. You need to do this early on so the water has time to boil. Submerge your metal so that it will equilibrate temperatures as you go, and so that you can assure yourself that it is the same temperature as the water throughout the heating process, and that it is equilibrated fully when you eventually move it to the cold water. The next thing you want to do is assemble your calorimeter. You will stack 2 styrofoam cups on top of one another, which will insulate your system. Next, tear the balance and weigh your cup. Make sure to record this value. Next, add an appropriate amount of water that it will just barely submerge your metal bar. Then, weigh your cup and water together. You can weigh by difference to find the mass of the water. Next, take your alcohol thermometer and measure the temperature of your boiling water. You cannot assume it will be 100 degrees exactly. Don't leave it in throughout the experiment. It's easy to hit the thermometer and spill the entire beaker onto your bench. Next, use your forceps to grab the metal from the boiling water and transfer it to the calorimeter. Cap the system and slide your probe through the cap into the system. Use Logger Pro to measure the temperature of the cold water before and during the heat exchange. Find the maximum temperature of the system to find when the temperature has equilibrated.